Hi everyone, this is Soumyadip Paul, a mentor at Code Cardos and a software developer at Amazon, and I welcome all of you to day 16 of our system design series. Now in the previous video we learned what is CAP theorem, and I told you that we will be learning soon how to make our system as fault tolerant, as partition tolerant as possible. But before we jump into that, we need to learn another important concept, which is called as scaling. Okay, now what is scaling? Scaling means making your system adjustable to different levels of traffic. Okay, to different levels of traffic. Now what do I mean? Suppose, for example, you are an entrepreneur and you have built a new system, a new software, a website or an application, and now there are a lot of traffic. There is, you suppose you launched your product, your app or your website, and now a bunch of people are using your product, and let's say on an average every single day about 500 people are using your website, which is fine. Fine, wherever you have deployed your system, it is working fine. They're able to handle those 500 people. Suppose all of a sudden your website becomes a huge hit and there are 5,000 or even 50,000 people visiting your website every single day. Now the same system may suddenly crash because that system where you had deployed your system, where you had deployed your website, may not be able to handle 50,000 people, 50,000 users every single day. But if it is able to handle it, that means your system was able to scale automatically. Maybe automatically, maybe manually, but whatever it is, your system was able to scale to adjust to higher levels of traffic. Again, say the traffic reduces. If the traffic reduces, great. You may adjust your system to use less resources, or you may keep it as it is. Though a good developer reduces the number of resources if the traffic reduces. However, we won't go into that. We want to understand what is scaling. Scaling is basically having a system which is smart enough to adjust itself based on the levels of traffic it is receiving. And if it is doing that, then we say that the system is scalable, that the system is basically scalable. Okay, the system is scalable. So as good developers, it is our job to build scalable systems. Okay. Now there are two types of scaling. The first is vertical scaling. And the second is horizontal scaling. Don't worry, we'll understand both of them. Okay. The second is horizontal scaling. So suppose you built your own website and you built it in a CPU which has some RAM, which has some memory, etc. Okay. Say you have a 8 GB RAM. Okay. Say you have 8 GB RAM. Now it is able to host some, it is able to support, it is able to supply to some, say 500 users. Now obviously it may or may not be able to support more users, but we're not getting into the nitty-gritties. I'm just giving you a broad example. Say your 8 GB RAM is now able to support 500 users. All of a sudden your website becomes a hit and you're having now 1,000 or even 2,000 users instead of just 500. So then you thought, oh, maybe instead of a 8 GB RAM CPU or 8 GB RAM server, maybe let me have a 16 GB or maybe 32 GB RAM. And you're like, oh, things are working fine, cool, great, everything's fine. I have upgraded my server from a 8 GB to a 32 GB. And it is able to host and support number of consumers, number of customers from 500 to 2,000. Okay. So you are having the same you are having the same number of systems. You earlier also you had one server, one CPU. Now also you have one server, one CPU, and you are increasing the specifications. This is what you're doing. You are increasing the specifications. Okay. So you're increasing the specifications means you're allocating resources, you can say bigger resources, or you can say allocating resources of higher caliber. Okay, you're allocating resources of higher caliber. But a very obvious problem here is that there is a limit, isn't it? There is a limit. There is a limit. You can have a 32 GB server, you can have a 64 GB server, a 128, a 256, a 512 GB server. But there is a limit, isn't it? Suppose you have millions and millions of users, like all the modern websites nowadays, say Facebook, Amazon, etc. You cannot have just one server. It will reach a limit. So what you start doing then is you start having horizontal scaling to solve our scalable purpose, our scalable problem. This reaching a limit is a scalable problem. So it basically has two problems. First is that there is a limit. Second problem is that it is a single point of failure, SPOF, single point of failure. Everything, all the users are all served by the same server. By chance, if this crashes, your entire website goes down. All your users, all your customers get disappointed. So these are the problems in vertical scaling. Problems in vertical scaling. Okay. That there is a limit and it is a single point of failure. Okay, and these are also called as scalable problems, to solve your scalable problems in vertical scaling. So horizontal scaling then comes up, which solves both these two problems. How does it solve? So vertical scaling is basically a way of scaling where you don't increase the specifications of a single server. But what you do is you have multiple servers. It can be a server, it can be a database, it can be anything. Basically, I mean to say you have multiple resources stacked parallelly. Okay, stacked parallelly. And each dividing the whole task at hand. Dividing the whole task at hand. Okay. So an example of this will be, say again you have a server which is of 8 GB RAM, and this is supporting 500 customers every single day. Now suppose your website becomes a hit and it has 1000 daily customers, 1000 daily active users. Then instead of increasing the specification of this from 8 GB to 16 GB RAM, you plug in another 8 GB RAM. Suppose it becomes from 1000 to 2000 daily active users. Then you plug in 2 more 8 GB RAM servers. Or you may have 2 16 GB RAM servers. So you can either have 4 8 GB RAM servers or 16 8 GB RAM servers. Okay. But the main funda is that you add up multiple servers parallel. You add up multiple resources parallelly. So now this server handles 500 users, this server handles 500 users, this also handles 500 users, this also handles 500 users. And in total you are able to handle 2000 daily active users. This is called as horizontal scaling, where you scale horizontally by adding more resources horizontally. Okay. Now this solves your problem of reaching a limit because now there is no limit. You can plug in as many servers you want. And also it also solves the problem of a single point of failure, because now even if one server fails, even if this fails, only the 500 customers which it was serving will get affected. The others won't get affected. And now these customers can also be served by the others. The load can be redistributed. The load can be redistributed here. Okay. the load can be redistributed if a particular node, if a particular server fails. So suppose this particular server failed, then the other 3 servers, instead of serving 500 customers, they can serve something like 700 customers, 700 customers, 700 customers, which will be enough to serve the 2000 daily active customers, daily active users. Okay. So now horizontal solves my limit problem and my SPOF, which is single point of failure problem. Okay. Now, there are problems with horizontal scaling as well. But that is something we'll see in the next video. Till then, keep practicing, and if you want to learn these concepts in a much more in-depth manner and prepare for Mang level companies, straight away from developers who have 5, 6, 7 years of experience working at Mang companies, then do join CodeGardos. And I'll see you all in the next video.